What's up everybody? Today I have the most ambitious repair project I have ever attempted. This is going to blow everything else out of the water, and I hope to God it works out. I don't think it will, but it might. Today on the bench we have this GIGABYTE GA-7ZX, which came from the scrap and has been utterly gutted by the previous owner. And I mean gutted in the literal sense. Look at this! The caps are missing. The ICs are missing. MOSFETs, who needs those? PWM controller, who needs that? MOSFET drivers, who cares? Diodes, gone. Capacitors, gone. Clock generator, gone. 245 buffers, gone. UART transceivers, gone. Crystals, gone. Op-amps, gone. Even more MOSFETs, gone. 7805 voltage regulator, gone. Battery circuit is gone.
No dates, no charge cards, no television, no movies, no phone calls, no food!
But here's the absolute kicker. You see this? This is the North Bridge. You see what's been done to it? Somebody used a screwdriver and levered off the heatsink of the North Bridge. But you know what? Don't even care about that, because you have a new one. It's reballed. It's excellent. But you know what? This is not a big deal, because I have literally everything needed to make this go again. And yes, these are all the correct parts collected from donor motherboards. So yeah, going completely against common sense, I decided to try and repair this motherboard. And the first thing to do is to replace the damaged North Bridge. The North Bridge is a BGA chip, and I have a replacement which I reballed from another board. So here I'm preheating the board to about 140 degrees Celsius on my BGA rework station. Then blast it on top with the heat gun to melt the solder and take the chip off. As per usual, wick up the old solder. This is some really nice 4.9mm thick solder wick made by Erza in Germany. Probably my favorite wick of all time, but it's not exactly cheap. And then go over it to make sure that every pad is able to accept new solder. You may have noticed that I ripped off a pad on the left side. That's okay because it's not connected to anything. Then wick that up. And give it a good clean. We did scrape off the solder mask in some places with the wicking, and we don't want any balls to short when soldering, so let's fix it with some UV solder mask. Now comes the moment I was dreading the most, which is soldering the new North Bridge. I first of all preheated the board to about 140 degrees Celsius again. And then dumped a whole bunch of flux on there. I placed the chip and then fine-tuned the position using some tweezers. And then generously applied heat from the top. You can see here the chip slowly lowered its position, gave it a little bit of a push to see if it snaps back in place, indicating that the chip has been soldered properly. Looks good from the outside. A quick test with the multimeter afterwards revealed that there were no shorts on any voltage rails, so I decided to continue. First of all, by fixing some of the problems that the board had with existing components, such as this TL431 voltage reference just hanging in there. I sadly broke the smaller nozzle for my heat gun, so I could only fix this kind of component with the soldering iron. And then wicking up the pads of the gutted components so that we can solder new ones on. Oh, well, that leg's gone. Another very important step in preparation, cleaning the holes of the desolder through-hole components.
Prepare for repopulation.
I sense some NES music with a repetitive task coming up. Oh, that's right. We need to put the capacitors. We finally reached the point of no return. Put in a BIOS chip. I flashed the latest BIOS for this board on there. And this is it, the moment we've all been waiting for. I put a plastic shield in there for protection, in case things go, you know, pew. And it's stuck in reset. Well, that's a load of shit. Okay, it's actually not a load of shit, because the board coming out of reset depends on a few factors that we can easily verify. For example, if all the voltages are there, such as the V-core. And the V-core is completely dead. There was this resistor here that had some voltage on one side, but nothing on the other. It doesn't reach the top. Ah, this is not soldered correctly. It's R367, which connects the voltage sense pin of the PWM controller to the V-core. Without this thing will just time out and shut down because it thinks there's an error condition. No wonder this thing stays in reset. Turns out this resistor wasn't soldered properly. Ooh, it comes out of reset now. Excellent observation, past me. The board comes out of reset now. It also has V-core now, 1.87 volts. I think that's okay for a Duron 900. But the board didn't do much more. One thing that was a huge relief was that the clock generator was working and all the clocks were normal. 14 megahertz, CPU clock, RAM clock, PCI clock, all there. But then I realized, well, there's a problem. Yeah, I forgot something. This op-amp is used in the voltage regulation for the North Bridge. Go figure. Nope. 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 There. To power the North Bridge. Oi, oi, oi! No way, man! It fucking works!
It works perfectly.
Oh, I did a successful reball!
Yo.
Does it enter the BIOS, or what is it doing now?
Well, I need to find my keyboard underneath all the rubble.
All the rubble.
But keyboard doesn't work, doesn't get power.
Oh
yeah, somebody took
Yeah, polyfuse.
Lols.
This is not a surface mount polyfuse like you'd find on other boards of this generation, but instead it's a proper like through-hole fuse. So I had to go steal that from another donor board. Okay, BIOS. Yes, the keyboard works. Nice, man. Oh look, onboard legacy audio, Sound Blaster, enhance Etapi performance. The fuck does that mean? Had to test AGP, of course, very important.
Hey.
AGP works too. To complete the ensemble, I soldered in the UART transceivers, which I left out because they're not necessary to test it. Keen observers may have noticed that there are unpopulated solder points for an ISA slot. In part due to my morbid curiosity and also peer pressure on Twitter and Discord, I figured I gotta check that out. And the verdict is in! The ISA slot works completely fine without any modification whatsoever. Did a few more tests, booted off the CF card, ran a few benchmarks, the board is rock solid. I even put a new Northbridge heatsink on there, using some thermal glue. This is a perfectly restored board and I cannot believe my luck. Here is the complete list of parts I had to replace or add. Hold on tight. I'd like to take this opportunity to pay my respects to the dead motherboards that acted as parts donors in this project. ECS 741GX-M, Asus A7 Pro, Asus A7V, GIGABYTE GA-586TX3, ECS K7VZA, MSI KT6 Delta, ASRock K7S8X, MSI MS6190, ABIT BH6, and GIGABYTE GA686 LX3. That's enough of that shit. Thanks for watching, I'll see you in the next one. Peace!